In this video, I will detail how to set up your assembly for analysis. Some of you are very experienced in SOLIDWORKS, and so the description on the assignment page might be sufficient for you. My suggestion would be to watch this quickly once, because you'll want to stop where I add friction to the contact mate. And you'll want to pay close attention to that. But as far as putting in the parts, this is probably easy for some of you and perhaps new for others. So what I did was I just started a new assembly, and when I start a new assembly, I have here my open documents available. So I have my crate and my floor open. If you don't, just click Browse and go find them. Now, when I am putting in components, I choose usually to tack open this window with the thumbtack so that I can add all of my parts at the same time. So I press the thumbtack, I'm going to choose the floor, and then a nice handy trick, and some of you might not know this, is I can put that right on the assembly origin if I turn on the visibility of origins. That's the eyeball at the heads-up display, and then click when it is coincident with that origin. So that puts in a floor and gets ready to put in another. I don't need another, so I switch to the crate, and I will place a crate into the assembly. Checkmark finishes this step. Now I usually put in the stationary object first because it fixes it in place. This floor will now not move. If I had put the crate in first, the crate would be fixed in space, and while I can fix that, I can unfix it. I can float one of the components. Usually I just choose to put in my fixed component first. So now I have, just to show you which toolbars I have on, I have my assembly toolbar on, and that's really the only one I'll use here. I can choose to set up relationships between these components. It's called mates, it's the paperclip. And I want to make sure that this box is over the floor, so I'm going to set a constraint there, but I'll choose a distance constraint because my floor is a little bit wider than my crate. Looks like 100's too much, so oops, 500 is definitely too much. I think I meant 50. 50, oh, it was just my angle. Okay, I'm going to try 100 again. And there it is. So I was at a funny angle, it made it look too much, but 100 millimeters for this distance, checkmark puts the mate in. I also want to make sure that it's in contact in this vertical direction. So I'll just put a coincident mate there, checkmark puts it in, and then I also want to put a starting condition where the edge of the crate starts at the edge of the floor. That will make measuring easier for me later. So now you can see how I'm set up. The final thing I want to do here is, there's actually two pieces I need to do. First, I want to name these mates, so I'm going to double click on distance 1. That's my distance from side. And then coincident 2, this is my floor contact. And the third one is my start condition, suppress. And so I'm making a note to myself that I want to suppress that relationship when I start my simulations. It looks like it's going to take 2 videos to set this up. So I'm going to pause here and get into the next video and show you how to, number 1, add friction into a duplicate floor contact mate, and number 2, set up your first motion study so that's ready to go. So this is the second video. We have 3 mates set up, and we don't have any motion studies set up yet. So one thing I'm going to do right now is suppress the floor contact mate and drag this up off, mainly because then I can see the surfaces I want to do. And my goal here is to add friction for our friction analysis. So I'm going to choose the paperclip, and then I choose the bottom of the crate and the top of the floor, and I want these to be coincident. That is the same as our first floor mate. But now I want to select the analysis toolbar. And here I can change some of the mechanics of the mate so that I can do some analysis with it. I just want to select friction. And rather than specify materials, I'm going to specify a coefficient. 0.1 is plenty. And then I've done a lot of playing around with these factors. And what worked best for me was to set the length equal to the length of the floor. So that was, I think it was, we'll try 3,000 here. And I'm going to pause. So as I mentioned, we're going to specify the coefficient, and we're going to look at these dimensions. 3,000 is the overall length of the face, but we are going to use, so what I've found works well is 2,000 here, and then the width is clearly supposed to be the width of the mate, and that's a 500 millimeter edge on that box. And then I've found that the joint dimension here does not affect the outcome of the simulation in this simulation. So these are the numbers. I've been working with a little bit of testing this feature out to try to come up with some realistic simulation results. And this seems to work. You can I think it's that we can increase this number without greatly changing the simulation oh no, so if you increase this much beyond 2,000, the simulation results are much different than expected. And if you set it to 500 by 500, which you might expect from this diagram, there's so much friction it doesn't move at all. So I haven't found a good explanation for what the joint dimensions define in SolidWorks, and I would recommend just these settings. Keep in mind, right, we did a coincident constraint between these two faces and then set our coefficient and our planar joint dimensions. Checkmark puts it in, and now I'm going to unsuppress it. I am going to suppress the start condition. And this is the steps before starting a motion study. So I'm going to suppress the start condition because I never want that active. I'm going to save my assembly. Okay. And I'm going to come into a front view and turn off visibility of my origins. And now I'm ready to start a motion study because this is my default configuration for the motion study. It just helps to get it all set up. So in this first motion study, I'm going to do force only. So I rename it, which means I want to turn off, I should have renamed this, I should have renamed this mate. So this is friction with floor, right? So I come back into force only. I'm going to turn this mate off or suppress it, and then I'll add gravity in the Y. I'll add a force along this edge in this direction of 175 newtons. And it's all grayed out because I wasn't in motion analysis. And then I will set my motion study to 1.5 seconds. And there's my first motion study. And it appears to be working as expected. And now you can measure the distance, if that's what you want to know, by turning on your measure tool and selecting the two parallel faces. The measure tool is on your tools toolbar. When I'm ready to start my next motion study, I'm just going to duplicate this, and this might be force with spring, okay? Or I can duplicate this and make it force with friction. And the last video cut me off, so what I was showing you is that you can duplicate your studies. So now force with friction, for example, I would come here. I usually suppress the, oops, I must have a tool on. I do. So I would suppress the original floor contact and unsuppress the friction contact. And fingers crossed that this works as expected. There it is. My crate moved. It's good news. So that's my force with friction. And then force with spring, I can set up a spring in this one, but I've already got gravity and the force all set. So how do we set a force with a spring? One of the things we need is a sketch that indicates where the spring is with respect to the crate. So on the front plane, I'm going to make a new sketch, and I'm going to select the box and make a horizontal line that is a 1/2 meter in dimension, in length. Okay, that's 500 millimeters. As a side note, I know some of you aren't super familiar with SolidWorks. You can always change your units down here, and I'm in the MMGS unit system. So there's my 1/2 meter length. I want to return out of the sketch, and what you'll see here in my motion study is that I can add a spring on the same toolbar where I can add forces and gravity. So I'm going to add a spring, and I need to explain two things to SolidWorks. First, where is it fixed, and then where is it where is it fixed on either end, really? I could put a spring on two separate crates and see how they affect each other's motion. But in this case, I want it to be fixed in space at one end, and I want it to be fixed on the crate at the other. So I don't actually want to select the sketch point over here, because that would fix it to the sketch in both ends, and that would result in a spring that does nothing. SolidWorks actually would give you an error. So instead, I'm going to fix the spring to the face of the crate. Then I can change my coefficient to match the instructions and set its initial length. I could make this spring longer than 500, and that would cause the spring to be pushing on the crate from the initial moment of the simulation, or less, and that would cause it to be opposing the motion right away. If I choose 500, it's neutral at the starting point. A check mark puts it in, and something I forgot to show here is that there are some display features here, and that is entirely cosmetic, so that does not affect how the spring works in the simulation. So quick review, I have gravity, I have a force, I have a spring, and I can calculate the motion. And so you might have noticed there, and actually I want to zoom in here. What you might have noticed is that we can see the spring stop the crate and reverse its direction of motion. Okay? So, so it's already affecting the motion as we would expect it. So if I review these three simulations, I have a force only, which results in the box moving almost the complete length of the floor. I have a force with a spring, which causes it to reverse direction once the spring is pulled to its point of most resistance. And then I have a force with friction that allows the crate to move uninhibited along the floor, but does cause it to move more slowly. So in the same 1.5 seconds, I don't get to the end of the beam as I did the first time. So review the assignment instructions. In both the force and the force with friction examples, all you need to do at the end is measure the distance between, using your measure tool, the distance between the face of the crate and this face of the floor. I don't want to spoil any results there, so I want you to measure that and compare it to your hand calculations and see if it makes sense. For the spring, you are going to have to plot either the acceleration or the velocity to compare with the request in the hand calculations. Ask if you have questions. This concludes the Jing videos.